For 5 straight years, the headlines all said the same thing. Electric cars had already won, and the combustion engine was finished. Tesla and BYD were supposed to leave the old guard in the dust. But while the entire industry poured billions into the battery arms race, Toyota was quietly building something that just detonated that whole narrative. They've unveiled a brand new micro-engine, small enough to fit inside a backpack, that Toyota's own engineers say is capable of unleashing up to 600 horsepower, built on a combustion platform targeting a new world record for thermal efficiency, pushing past the 41% mark Toyota has held since 2016. This isn't a hybrid refresh. This tiny engine is stealing Tesla's biggest aerodynamic advantage, gutting the anxiety around running out of charge, and rewriting what a green car even means, without asking you to sit at a charging station for half an hour. So why is the world's largest automaker betting everything on pistons again? And is this the engineering breakthrough that finally puts Tesla and BYD on the defensive? Let's take this apart piece by piece.
Why the EV hype hit a wall. The first wave of EV buyers were true believers, early adopters who didn't mind planning road trips around charging stops because they were sold on the future. That crowd is basically tapped out now. The next wave is the mass market, and mass market buyers don't want to compromise. They want a car that works the same way every single day without asking them to change their lifestyle around it. That's a fundamentally different psychology than the one that powered the first decade of EV adoption, and it's exactly the gap Toyota is aiming this new engine platform at. The cracks are showing. Charging infrastructure is unevenly built out, and popular corridors turn into genuine bottlenecks over holiday weekends. Extreme heat waves and deep freezes put real strain on regional power grids, and that strain tends to peak at exactly the moment demand for charging is highest. Then there's a physics problem no software update can fix. Cold weather can gut usable EV range, with real-world testing from outlets like Recurrent Auto showing drops of about 30% at around 20 degrees F or -7 degrees Celsius. On top of that, EVs have earned a reputation for steep depreciation, and an out-of-warranty battery pack replacement can run into the thousands of dollars. Range anxiety, resale uncertainty, unreliable charging, a growing slice of would-be EV buyers are quietly drifting back toward hybrids instead.
Inside the 600 HP micro-engine. Here's where the engineering gets genuinely wild. Most conventional gasoline engines throw away somewhere between 60 and 70% of their fuel energy as waste heat. Toyota's current dynamic force engine family already set the industry benchmark at 41% thermal efficiency in hybrid form, a record the company has held since 2016. Now Toyota is chasing something higher still with its next-generation architecture. High-speed combustion, reworked intake tumble flow to burn fuel more completely, and a shorter piston stroke that Toyota's own chief technology officer has publicly called one of the hardest technical problems the team has ever solved. Toyota hasn't confirmed a final number yet, but everything the company has said points toward breaking its own record. The new lineup splits into 3 tiers. The naturally aspirated 1.5-liter is the everyday workhorse, about 10% smaller than the unit it replaces, targeted at roughly 94 horsepower on its own and over 134 horsepower combined once the electric motor joins in. The 1.5-liter turbo is built for plug-in hybrid platforms that need more low-end torque without giving up efficiency. And then there's the headline act, the 2.0-liter turbo codenamed G20E. Toyota's engineers told the German outlet Automotor und Sport this engine is on track for 400 to 450 horsepower in its Gazoo racing form, and that with a larger turbocharger, more than 600 horsepower is, in their exact words, easily possible. Put that number in perspective.
Right now, the most powerful production four-cylinder engine on the planet is Mercedes-AMG's hand-built M139, a 2.0-liter unit that tops out at 415 horsepower in its original S-spec form, with the latest evolution of that same engine pushed as high as 469 horsepower. Toyota is talking about pushing the same displacement class well beyond even that ceiling. The reason it's even mechanically possible comes down to how the block itself is built, a reinforced closed-deck cylinder architecture that can handle far higher boost pressure without the cylinder walls flexing under load, paired with a turbocharger sized to survive sustained high RPM abuse rather than short bursts. That's the same fundamental approach AMG used to get the M139 to survive over 200 horsepower per liter of displacement, and it's exactly the kind of structural over-engineering Toyota's team has said they built into this block from day one, a deliberate safety margin most modern thin-wall aluminum blocks simply don't have room for because they're optimized for fast warm-up and low emissions rather than absorbing triple the factory boost pressure. Backing all three engines is a new power control unit making torque blending decisions in milliseconds, killing the laggy rubber band feeling that's plagued older hybrid transmissions. The result is instant electric torque the moment you touch the pedal, with the combustion engine stepping in seamlessly the instant you ask for more.
The weight and Aero trap. Here's the part die-hard EV fans don't want to hear. Batteries are heavy. A typical EV battery pack weighs anywhere from 1,000 to 1,500 pounds, sitting low under the floor. Take the Tesla Model 3 long range as a real-world example. Its curb weight sits at roughly 4,021 pounds, or about 1,824 kilograms. A Toyota Camry Hybrid, by comparison, comes in around 3,450 pounds, or roughly 1,565 kilograms. That's about 260 kilograms, call it 570 pounds, or about 3 grown adults the hybrid simply never has to carry, which means less wear on tires, less strain on brakes, and a lighter footprint on the road itself over the life of the car. Shrinking the engine changes the entire shape of the car sitting on top of it. A smaller powertrain means engineers can drop the hood line lower, and a lower hood line means less frontal area pushing through the air. Toyota's new engines cut engine volume by up to 20% and height by up to 15% compared to the units they replace, freeing up space to chase drag coefficients that used to be exclusive territory for purpose-built EV platforms. The current Tesla Model 3 already posts an impressively low 0.219 drag coefficient, achieved specifically because the car never had to package a bulky combustion engine up front and could be sculpted from a blank sheet around aerodynamics alone. Toyota's bet is that a smaller, lower-mounted engine can now chase that same number from the opposite direction, cutting drag not because there's no engine, but because the engine barely takes up any space at all. Less weight also means less rolling resistance, which compounds with the aerodynamic gains to squeeze even more distance out of every liter of fuel.
Toyota versus Tesla, the repair math. Put a hybrid and a battery EV side by side over a year of real ownership, and the math is stark. A 3 to 5 minute stop at a gas station delivers 800 to 1,000 plus kilometers of range. Even a best-case supercharger session can add up to 175 miles of range in 15 minutes before factoring in a wait for an open stall during a busy travel weekend when every minute matters and lines start forming at the fastest chargers on the route. Then there's the number that should really worry EV owners: repair costs. According to a widely cited report from CCC Intelligence Solutions, repairing an EV after a collision runs roughly 23.5% more expensive for vehicles 3 years old or newer than a comparable gas-powered car, largely because Tesla's structural battery packs and gigacast body sections are essentially fused into the chassis. Damage one corner, and you're sometimes replacing a massive single-piece casting instead of a handful of bolted-on panels. This isn't theoretical. In 2024, Hertz moved to sell off about 30,000 EVs from its rental fleet, after initially targeting 20,000, specifically citing high collision and damage costs, with the company's own CEO stating on an earnings call that EV repairs were running about twice what a comparable combustion vehicle cost. Toyota's modular, standardized components represent the opposite philosophy. Parts built to be fixed at any independent mechanics shop using a technician base that's had a quarter-century head start.
Toyota versus BYD. Cheap versus trusted. BYD has built an empire on aggressive pricing powered by its blade battery technology, undercutting nearly everyone else in the market. On day one, that's a genuinely compelling pitch, especially for budget-focused buyers. But Toyota is playing the long game, and the scoreboard backs it up. According to Toyota chairman Akio Toyoda, the company has sold roughly 27 million hybrid vehicles globally since entering the segment, a track record no other automaker on the planet can match, built on decades of parts availability, supplier relationships, and technicians who don't need specialized high-voltage training just to service the car. That real-world reliability data shows up exactly where it matters most to the person signing the check: resale value. Toyota hybrids consistently hold their value better than EV alternatives that tend to depreciate fast the moment a newer, longer-range battery generation hits the market. Zero emissions without the grid. Here's the strategic masterstroke underneath all of this. These new engines aren't locked into gasoline. They're built to run on synthetic e-fuels, advanced biofuels, and liquid hydrogen, which means Toyota can chase real emissions reductions using liquid fueling infrastructure that already exists worldwide, rather than waiting for every country to rebuild its power grid first. It's a different way of doing the full life cycle math. An EV's true climate benefit depends heavily on how clean the electricity grid charging it actually is, and on the mining and processing footprint behind the battery itself, variables that shift drastically from one country to the next. A liquid fuel platform sidesteps both of those variables by working with fuel infrastructure that's already built, already global, and already understood by every mechanic on the planet. That matters enormously outside wealthy EV-friendly markets. Southeast Asia, Latin America, most of Africa, and rural stretches of North America and Europe don't have reliable charging networks today, and realistically won't for a long time. Toyota's bet is that cutting emissions across tens of millions of affordable hybrids does more real-world good than selling expensive battery-only EVs to a narrow slice of buyers wealthy enough to own a home charger. It's also a quiet vindication for Akio Toyoda, criticized for years for refusing to commit the whole company to battery-only vehicles, right as EV sales growth has cooled globally and other automakers have quietly walked back their own all-electric promises.
The final verdict. Toyota didn't kill the electric car, and that was never really the point. What they're building is something more pragmatic. A powertrain that feels like an EV around town, drives like a genuine sports car when you want it to, and never once makes you think about finding a charging station. That's not old technology dressed up in new packaging. That's Toyota actually solving the problem regular drivers have with modern transportation right now, with hardware built to survive real-world abuse rather than just look good on a spec sheet. And if you want the next engineering breakdown the moment it drops, including the next battery showdown we've already got in the works, make sure you're subscribed so you don't miss it. So here's the question worth sitting with. Did Elon Musk and BYD underestimate just how much life was left in old-fashioned mechanical engineering? Or is Toyota's micro-engine just a clever way of buying time before the electric revolution finally, inevitably, arrives anyway? Drop your take down in the comments, because I can already tell you not everyone watching this is going to agree. See you in the next one.